Is that the right window, Yatu? Yep.
Yep.
What you can see in my background, it is not a virtual background, it's a real background, and that's the visualization lab here at Pawsey that you can come and use the big display. We will talk about the details, the technical details of that display. But for now, we start the presentation. If that's the right time, Edvik, or we have to, or we can wait like another 1 or 2 minutes for everyone to join.
I think we're good to go.
Okay. Sure.
I think we've got a decent chunk of people have managed to make it in.
Sure. Hi again, everyone, and welcome to visualization presentation for internship 2022-3. And I'm Ali, and my colleague Yato. We are from the visualization team at Pawsey, and I'm so glad to present the visualization services to you guys. Just feel free again, as I mentioned, to stop me, to jump in, unmute, turn on video. Don't feel shy, ask question, a stupid question, very welcome. And I'm sure you are very sophisticated in the visualization and in supercomputer knowledge by all of the training that you have received so far. But this would be a little bit different because it's like a GUI involved, and we'll have very like beautiful, interesting, and fancy outcomes out of the visualization. So what we cover today is talking about the visualization concept itself. What is the visualization exactly? Why it is required? And what do we offer at Pawsey as visualization services, showcases, as well as the expertise, and some outcomes that has been done by other projects already. Also, I will try to make some time to show you in interactive session how you can use the visualization services, basically remote visualization. Everything's here remote except the background of me, which is the visualization lab that you have to come physically here. But the rest is accessible from everywhere, basically, as long as you have internet connection as well as a browser, a web browser, that would be enough. It's everything like touch enabled, and I think the tablet would be the smallest size that you can you feel comfortable working with the system. And yeah, the concept of the visualization is talking about the methods or the techniques that you use to see the result of your simulation. The purpose of the visualization is that you do your simulation on supercomputer, you have the outcome, and then you want to see the results in some like meaningful way, in kind of immersive and having like more insight into the visual, into the data, into the result of simulation. So that's when visualization come into play and helps you to understand the result of your simulation in better way. So also one point to have it in mind, whatever that you can do here on supercomputer, on visualization services at a supercomputer center, it is all doable on your own laptop, but for a small, tiny portion of the data that you generate on supercomputer. So For example, here we are talking about terabytes and petabytes. At your computer scale, we are talking about megabytes, kilobytes, or if you have very sophisticated, very expensive system, you spend a lot of money on your system, good GPU and powerful CPU, maybe we have it like up to terabytes. But we'll talk about this more, but just to make it distinguished, that the difference of the visualization at the supercomputer and your local system is all about the scale. So managing the very big chunk of the data at a very short time. That's the whole point about the supercomputer and visualization indeed. So basically, as I said, after simulation done on supercomputer, outcome would be a series of the numbers, and that you don't have any idea what does it mean, you know? In very like the easiest way, you can extract some CSV data, for example, to plot bar chart or like pie charts in Excel, the Microsoft Excel. But apart from that, if you want to do something like this, like imagine you have done your simulation working on the speed of the atoms, like moving around the core, and then you are presenting your simulation result by a series of numbers which is boring for audiences, and they don't have any ideas. Just imagine the impact of your presentation or your research or your simulation versus when you have the result of your simulation visualized in this beautiful, meaningful, and understandable for every level of knowledge. So by this, you can basically improve your outreach. You can increase the level of understanding of your research for wider range of the people and the different fields of different scopes and different fields of the science. And to do that, you have to come to this visualization technique. So we have different services that makes or facilitate this for the scientists, for the researchers. By accessing those services, that would be achievable to do something that you saw in the previous slide. Okay, so far everything's clear, or you have any question on the visualization concepts and the techniques that we use for visualization? Please feel free to unmute yourself and jump in, ask question, and participate in the presentation. Basically, we love to hear from you. So I'm sure that you guys are from different backgrounds, and you should have some very interesting stories to share. No one?
Well, I can just say personally, for me, big challenge is doing stuff with quantum mechanics, where we've got these really high dimensional systems that you can't visualize in, just directly in 2D or 3D. So I feel like a lot of our work is figuring out how to create something that conveys that idea. That's
one of the first questions that comes up in most of the people. There was a very top scientist in the conference that we had a month ago, Pecan, that they were from the astronomy, and they asked how to visualize these numbers into like a picture, even 2D, not even 3D. And that's very it's not a stupid question at all. That was my question at the first time that I started to pop in to the visualization board, it is obvious, and you need to get, like, when you want to write a program, you don't know, for example, programming or which language do you use. For you can use, for example, that's the most efficient the language or the approach, for example, for parallel programming or like GPU programming. All of this you have to like know about that a little bit. So that's what we are going to do today, just to give you like a very a small step in the start of starting your visualization, and think about visualizing your data. That sounds great. You shared that with us. Thanks, Edric. And other people, please feel free to jump in. Don't feel shy. We are here to answer the questions. So the visualization services that helps you do visualization. Basically, you do your visualization, you do your simulation on supercomputer, and you have a bunch of data that you want to visualize. So this is very important to understand. What's the best service or what's the best method, technique to do for visualization? Because that's like variety of, there are millions of ways to do visualization. You have to go for the most efficient way. That's true that we have a lot of resources here, and that would be 100% true that running simulation or visualization here at the supercomputer facility would be faster than the personal computers, but it doesn't mean that you don't have to go for the most efficient one. So it doesn't make sense. Just to get fair use of the system, have the resources free for others to use, as well as achieving the results as soon as possible for yourself in the shortest possible time. It's good to know the most efficient methods to set your pipeline and strategic pipeline, basically. So we have all of our services accessible remotely. You don't have to come here physically, except this visualization lab. So for VR, if you need like a local access, just like physical access to this room, you can do VR here as well. But even for the VR, that's in early adopter phase, but that will be released soon, that you can connect to our systems with your VR at home, as long as you have very solid connection, sorry. You can use the remote VR even. So what's the difference? Again, in scale. So if you are familiar or you have a VR headset at home, you can do it on your personal computer, but for a small chunk of data. But having terabytes or petabytes of the data visualized needs very powerful system. And basically with that remote VR, you are connected to our system, and then the visualization will be streamed into your headset at home. Anyway, so yes, remote viz, that's the name of the system, which is Linux based. Basically, that gives users a Linux desktop, and then they can like open the application in that desktop and do their visualization. Nebula is the name of the other system, which is Windows based, but it is not limited to Windows. You can request for installing any operating system, Ubuntu, Linux, Arch, whatever that you like, we install and give it to you. Just as a comment, Remote Viz, which is the Linux base, is on Cetonix nodes, whereas Nebula is on separate small cluster sitting next to the supercomputer. VizLab, which is here, and the VR that I explained already. Carta is, again, another web-based visualization tools for the astronomers, and expertise that we are here, and we love to be involved and help you guys to do your to design your workflow, basically your visualization pipeline. So basically, as you can see, almost everything here is remote, and all of them are like accessible, almost all of them, in the web kind of interface. So as long as you have tablet or like iPad, big enough for you to feel comfortable. I don't feel comfortable on mobile, maybe you do, so you're welcome to try on your mobile. And then a web browser, that's enough. How? I will show you how does it work. And so on client side, basically on user end side, you don't have any like crazy machine or like powerful resources at all. No GPU, only CPU, a web browser is enough, and internet connection. So if you remember, we talked about the speed. So whatever that you do on a supercomputer facilities, you can do on your machine as well, on your workstation, on your laptop. But it's about the speed and about the size of the data that you can interact with. So in a standard laptop, while you are still waiting for loading, if it doesn't crash, you have loaded your data and you have done your simulation or visualization on HPC Center. So what we are talking about is just this scale. So the remote visualization, as I mentioned, is the way that you can access the visualization facilities here. Basically, if there's no remote kind of accessibility to the system, you have to come here, sit next to the machine. It's a very noisy environment, and connect your keyboard and mouse and monitor there to work with, right? But remote visualization gives you the freedom of connecting to the same machines with the same experience. If you sit there next to the machine, connect the monitor there, that's the same kind of UI UX that you will receive, but remotely inside the web. So that's the basic concept of the remote. It's not the only reason. You can say that, oh, even for like supercomputer, we do SSH, and we connect everything like remotely. Yes, true. But in case of the visualization, we are talking about GUI. I'm not sure, maybe now is the best time to go on mute and come and participate in the presentation. In the supercomputing training that you have received, did you get any experience with the X11 as well? Or it was all about like SSH?
All about SSH.
All about SSH, right? Okay. So basically, this is something that you can Google it now or after the presentation. So in SSH, there's no GUI, and your command line, you're limited to the command line. And if you want to have some of the applications that you are doing simulation with on supercomputer to open in the GUI, basically you should have that application capability to launch the GUI. So if you go like SSH-X, that will be like helping you to launch the GUI, which is running basically on supercomputer. But there are some downsides with that. That's very cool. But if you lost the connection, if accidentally you close the window, or say the application crashes itself, everything's gone. Even you are in 99.99% of the process completed, everything's gone, and you have to start from 0%. Whereas in remote visualization inside web, if you lost the connection, if you you close the browser accidentally, if your computer was out of charge or restarted, you don't lose anything. I will show you again. And I will demonstrate this for you. And that's thanks to the setup that we have for the remote visualization. It is possible. So basically, as long as you have, again, other like you again recover your session somehow by having the internet reconnected again, or whatever, you log in back to your session and your session will be there. So that's as simple as this. Also, remote visualization, remote machines. I'm talking about the third item here. Remote machines can be any OS. This is your machine, the user end machine. So as I mentioned, even the iPad, iOS, iPad OS, Android, Windows, Linux, Mac, everything's, as long as you have a browser, that's enough. So you're not limited to any kind of crazy, you have the freedom and you have the luxury of going to the system that you live with, basically. How does it work? So you go basically to a web page like remoteviz.pawsey.org.au. You log in, and then you will be on login node. This is exactly identical to when you do SSH. When you SSH into Setonix, you are sitting on the login node. And then you can slog, for example, or you can launch a job, and then that job will distribute it, or that will be spawned on the compute node. This is exactly what is happening here, but in the GUI interactive way. You log in the web to the login node, and then you start a session, which could be application, either application or a desktop environment. And that goes on compute node. So basically, there's some load balancer in the background that looks after that one. And then you will be given the free node, and you do your visualization. So that was the remote viz, the Setonix remote viz, which is going to be released soon. We are still using Topaz, our like old system. Nebula is the one that we call it Windows cluster, but could be basically any operating system based on your request. So it is Windows 10, could be Windows 11, could be whatever that you want, Linux. And it comes with very many like pre-installed application, meaning you request having, say, TD Studio Max there, and then we install it and we image it and we give it to you. And the rest is as simple as running your application. But in the background, do not forget that many things is happening similar to the supercomputer. Here is the similar system that you can run job on, like distributed across nodes and in parallel. Talking about how to get access, I think there are enough stuff on visualization documentation that Edric or Yatu that will share it in the chat with you. Feel free to go through and get yourself familiar with how to access, or if you are interested to request, we are happy to help and give you access. That's simply sending application, and the rest is straightforward. But who's the Nebula for? Nebula, sometimes researchers have some applications for the visualization that is only developed in Windows, and there's no other distribution for Linux or Mac, or Linux basically. We don't talk about Mac here. So they have to be in Windows, and they need very powerful systems, same as the Supercom. So that's when Nebula come to help. When the other occasion that Nebula is super helpful for the users, that is when they have very GUI intensive kind of application, an application that works with the supercomputer, that launches the jobs on the distributed mode on supercomputer, it is capable of doing that, but it is in Windows. Or it is like very GUI intensive that needs very powerful graphic. Okay, now I expect you to ask question like this. Cetonix has GPU as well. Why Nebula is more suitable for this purpose? Do you have any idea? I'm trying to make this session as interactive as possible, and please jump in and unmute yourself. Don't be shy.
You'd be doing us a solid.
What's that? Sorry.
They'd be doing us a great favor if they came in with some great questions.
Right.
You know, then we know that we can. Then everyone will learn much more that way.
Yeah, sure. I'm sure. So basically, there's two things. On Cetonix, you can say there would be potentially two problems. One of them would be like, again, your access would be X11, and that would be, again, the same problems. If you lose the connection, if application caches, blah, 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 that comes to the whole purpose that we designed the remote visualization to overcome this this downside of the X11. Security is some other thing that it's quite obvious. If you go and search for the security of X11, you can see that it's not that great. Also, the GPUs on Cetonix are not the GPUs that you use at home, for example, for gaming. These are accelerator, basically. They are headless and they don't have graphic output. They don't have monitor output. Whereas for these GUI intensive applications, we are talking about those that they need like real graphic. So accelerators, that's all for running your simulation on GPU, which depends on the programming that could be much faster than running on CPU. So those GPUs are like more computational than graphical, but these GUI intensive application, they need like proper GPU with like real display output. So that's when this Nebula comes to help again. And when, for example, you have some application that your workflow is in multi-steps. ANSYS, if someone's from mechanical engineering or any CFD, maybe are familiar with. Material engineering, Aviso, for example. Oh, Aviso is not capable of running jobs on the supercomputer, but ANSYS, that's the best example that we have it here in service. So they have to design the geometry first, then running the simulation based on that geometry, and then visualizing the result of the simulation. Just imagine. And the geometry is big. We are talking about the geometry of, for example, a design of a dam, for example. So their computer should be powerful enough to do that design, to be able to do that design in that large scale with lots of parameters and data. That's one thing. Then they have to SCP or secure copy that geometry over to the supercomputer, do their simulation, and then they have to copy back everything, all of the data that was generated by the simulation to their computer to visualize if they have enough resources. So you can see how inefficient and clunky is the workflow. Whereas here, they can open the ANSYS in Nebula. They have very sophisticated, very well-equipped GPU system. They do the design of the geometry. They launch the job, which happens automatically in the background. They don't have to know anything about that. And then when the simulation is done, the result is automatically copied over back to Nebula for visualization. So even they can transfer data across system. It's just a matter of like minutes to visualize on remote viz, for example, if they are doing on Nebula, and vice versa. So you can see how helpful could be. This Sony crystal LED screens, that's a very interesting piece of tech, which is the latest technology of the Sony. It's 4K resolution in the dimension of that I've forgotten. Maybe yet we can put it in the chat. 5.5 meter in diagonal. So aspect ratio 16:9. If you are very into the tech, these numbers are very familiar for you. But the big difference is that it's modular. So it's not a big TV. It's like a collection of like 72 small units that each unit has a smaller unit consists of the 12 sealed panels. So 12 panels per each unit, and then 72 units generate. That's the whole scheme. So 72 times 12, so that's the number of the small pieces of like mobile size that you can imagine. I wish I could show you in the background, but anyway, the refresh rate is 120 Hertz. That's stereoscopic and very like high contrast. And even if you get like close to that one, like standing there, so it would be like very similar experience to the VR headset, because you can see yourself drawn into very like the big picture. And the VR, the virtual and augmented reality, the VR, as mentioned, it is with early adopters, remote VR. Here as well, we can provide you with the VR. You can come and use it. Would be different applications, but a specific design application for astronomy, iDavy, for example, and Cowise in the future, which is similar to ParaView, designed by HLRS in Stuttgart. We can give you access to that one as well. And yeah, for scientific use, this is what you can see on the shared slides is the ParaView, which is visualizing a micro city, which is 3D stack of 2D images from the reservoir rock sample. Basically, the concept is similar to radiology, to hospital radiology, like CT images, but this is like very high resolution. In CT image, the hospital, the medical one, we are talking about 1 millimeter resolution. Here we are talking about almost micron, like almost nano, like 5 micrometer or something. Sweet. So maybe 1 minute break, maybe helps to energize and come back again, or anyone has any question?
I have a quick question.
Sure, please.
So you were saying that you can use this visualization when you're running something that's like graphically intensive and like uses like an actual program. Do you still have to do all the work of somehow getting that program to run on a supercomputer?
Yes.
Or is it
Absolutely.
built more into the visual? Like you have to make containers for it and stuff.
You can use anything. The only thing is that application has to be programmed in a way that could spawn the jobs across nodes, or at least on like parallel, even on one local node can do the
proper
running job in parallel way. So single core applications, forget about that. So if you look at like each node of the supercomputer, even could be less powerful than your laptop.
Yep.
And the power of the supercomputer would be the combination of the summation of you know, the hundreds of the nodes that they come together and they run the job for you. So parallel running, if either CPU or GPU, and in the best case scenario, the distributed running across nodes. We are talking about MPI. We are talking about, you know, OpenACC. Your application has to be capable of doing that. If that's something that you are developing yourself, that's a must to do that. Otherwise, you can do visualization, single core, on very limited size on your laptop. There are pre-developed applications, very general use applications that we will talk about that very soon. What time is it? Am I behind? Oh, almost. I will go quicker. That they are like very general purpose. Paraview, for example, if you search that Paraview with view at the end and parapar, which is like parallel. It's from Kitware. If you Google Kitware Paraview, it brings you one of the, this is one of the most sophisticated, one of the best application suiting the visualization on supercomputer that can run your visualization on distributed node and distributed mode on entire supercomputer, either CPU or GPU. That's super, super powerful. Also, you are not limited to Paraview. VMD, for example, that's another application for molecular dynamic. Visit is another similar to Paraview. There are tons of applications, and each day, like the researchers request, and all we have to do is just like make it install for them and give them access. Sweet, thanks for the question. Yes, there are some applications, and you don't have to develop your own application. So the only thing is that you we can help you to set up your workflow or your pipeline, how to automate, for example, your application or your visualization, or we can automate the whole simulation and visualization together either. So you script it, and we give you like the best efficient kind of methodology. Then you run the simulation and you forget about that. And then you come and you have it visualized. So how cool is that for like terabytes of the data? Anyway, a very quick overview over the systems. As you can see, here is the remote viz, which is currently Topaz, soon will be Cetonix remote viz. Here is Nebula, and here is the visualization lab. All of them, they can connect to Cetonix and also the cloud, the Pawsey cloud, which is Nimbus. I'm sure you have already had training with that. Connecting in a way that you can transfer data. We are talking about the data transferring right now. So everything's happening through Akasha, and also the data mover node between the two sketches, between the visualization sketch and supercomputer sketch. Also that object storage Akasha, it is accessible from outside world by the end user as well. So basically, Akasha, you can look at that as archive tool as well as a gateway for transferring the data. And also a bridge to transfer the data between different systems. If you have done your simulation on Cetonix, you want to visualize it on Windows, all good. Just transfer the data through Akasha to Nebula and visualize it. If you want to do it on Cetonix remote viz, you don't have to even transfer the data. Scratch is already mounted there on Cetonix remote viz. If you want to visualize it here and present it to your audiences, don't worry. Again, either through Acacia or data mover node that transfer the data between the supercomputer Scratch and the Viz Scratch. You transfer the data and visualize it here in Windows or Linux. If you want to have a copy of the data to put that in your personal Nextcloud at home, don't worry, Acacia, and transfer it to home and keep a copy for yourself. You know, everything's possible. So application, we don't go through that. You don't have time, and you can get as much as information you want on in the documentation. The tools that you were a bit further than the presentation, and you asked already. PowerView, VMD, Visit, Maya, and Aviso. Okay, always I love to give this example. I'm sure all of you have watched Avengers, Disney Plus, and many of these are like 3D renders, and they have happened on HPC kind of infrastructure. It is basically possible to have similar system to SLAM on supercomputer on any system, even okay, so this system is called like render farm. So render farm could be happen on supercomputer as well. And then these commercial softwares, you were asking about the applications. Yes, commercial softwares also, some of them are capable of spawning and running jobs on the supercomputer on distributed mode. On HPC, it shouldn't be like supercomputer. We are talking about like clusters, you know. Some of them are like capable of doing that. Autodesk Maya, 3D Studio Max, Cinema 4D. What else can I remember? Blender. Blender is the open source one, the free 3D animation kind of tools that when you go to like big and bigger like projects, your personal computer won't be able at all to do rendering. You need like very good GPU with good CPU, still leader, and not powerful enough to do that. You can't do it on HPC system. So you can see you can do like wide variety of the task on the supercomputer's visualization. In situ, just to be quick. So far, we were talking about running simulation, saving the results or outcome, transferring to visualization infrastructure, Nebula, or not transferring if you are doing your visualization on Cetonix Remote Viz, and then visualize. So it means offline. But with that PowerView that I told you, at the same time, in real time, you can see the result of your simulation. Your simulation has been started. Even you can control your simulation inside the PowerView. You start the simulation and you see the result of simulation in real time in PowerView. And then you can see, oh, it is going wrong or it's on the right track. And if that's not, you can stop the job, you save on time on your allocation, core allocation, as well as making the resources free for others. So how cool is that? That's another service that we have here and you can use it. 15 more minutes. Showcases. To give you a very like quick glance on what is possible. This is a CFD kind of simulation, which is showing the result of a dam break. So what happens to that fluid? Could be anything, water or whatever. So you can see, for example, based on the color-coded legend, you can see, for example, when it hits to the wall, what's the speed, for example, how much pressure, or what's that makes that very easy to to explain the result of the simulation to the audiences. So this is another example for molecular simulation using VMD that we were talking about. Again, your simulation will show some parameters in numbers, very like the best way that you can show would be like some Excel sheets, but here you can show that in like animations and very like interesting way. The answers that I was talking about, this is on Nebula, and so they run, and at the same, this is like demonstration what is happening. They run the simulation. They open the job, open the GUI that launches the job on the supercomputer, and then they look, everything's in the windows. Whatever command line that you can see, that's for demonstration purposes to show what is happening in the background. You don't have to do that. You do the design here, like geometry design, and then you start the simulation. Simulation is running. You are receiving the results at the real time back. Let's make it like, yeah. You start the simulation. You are in Nebula. You are in Windows. You go for number of the iteration, 10,000. You start the simulation. Simulation is happening. And you can see it's diverging, converging in real time, like in situ. At the same time, this command line is showing that the job is running on node Z124, SSHing into 124, and getting top. It shows that the this is like very small case for demonstration purposes, 4-core kind of job, but you can see that it is happening. Like, yeah, 4 Fluent is running. So you can see that nothing you have to do, everything's happening in the background. So in the GUI, you are designing your geometry, you do your simulation, everything's happening in the background, and you receive the results real time back into the Windows. But everything's happening non-satanics. How cool is that again? So, and again, if you lost your connection, if you close the window, whatever, don't worry. You log back in and everything's there. This is like a spike protein. This has been done simulation by the Houdini. Again, same as the Autodesk Maya, or yeah, that's again, that needs a lot of resources, and you can use supercomputer to do that. This is like from Peter McCallum Cancer Research in Melbourne, that they did that with the Nebula. It's for the education purpose as well as the patient's awareness on the cancer treatment process. So they show how the cancers kills the cells, and how the medical treatment can fight with that. So you can see how going to immersive and very like high resolution the result could be presented to audiences again. So a lot of cool stuff you can do with the visualization. And then that GLIM which is from MWA Sky Survey, it shows the data captured by the MWA antennas, and the supernova, which I wish one of my colleagues that did that was here to explain more about that. But if you search for supernova, that's on the web, you can go and read more about that. But these are like, even this is like 2D visualization, but that's super heavy to visualize. So you need a supercomputer to put all of the data chunks together to picturize that one. Yeah, like turbulent flow in jet engine. This is another CFD example. not sure it was with the commercial software or they had their own package. I think that was like they had their own package. So they could, again, do visualization here that shows on how the flows and interacts with the turbine fans. And that's it for now. If you go to this link, you see the visualization documentation. Also, you can contact us through visualization@pawsey.org.au and help@pawsey.org.au. So I have 10 more minutes. If you have any question, please unmute yourself, ask the question. Otherwise, I can demonstrate a couple of the services that we have to see how does it look like. Any question?
I have one question.
Sure.
Is anyone using Blender for
Yes.
this one?
A group from UWA that's on top of my head, that they are doing medical research. I don't remember the name of the group or the name of that center, which they are cooperating with UWA using Blender. But yes, they are. And again, the way that you, as I mentioned, there are like millions of the ways to do your visualization. What's the best, most efficient kind of procedure? It comes to the aims, it comes to the type of the application you have, data format, and yeah. So Blender, for example, for that specific person or any other specific person, one of the most efficient is setting up render farm. Render farm could be on supercomputer as well as like on a small cluster, as many as or as much as resource you have. You can put them as a slave and then launch the job. The rendering will be broken down into like number of frames or like chunks that will be sent to each slave, and then the result will be gathered by the job coordinator and then stitched together to do your also sometimes you can see that, oh, that frame is not very like high resolution render. So you go to job coordinator, you go to that specific frame that was done with that specific node and you redo again. So you have like very complete control over the job. Blender is one of the most powerful 3D renderers programs.
Because I know I've found it to be pretty nice to use because it has that Python API. So
yeah. Basically, that was good to know that you have worked with that and you know that Python it has Python interface. The way that these commercial applications like Autodesk Maya or others, they do they are capable of running on like render farm and like distributed in like scale, let's call it, is that they have like a they contain a standardized Python API to interact with other instances. So yes, some of those there are like plenty of open source job coordinators that thanks to this Python interface, Python API, so they can speed up the rendering like in a factor of many. Sure, I think there's no other question, right?
Well, I guess another question I have is I think a lot of the projects here are in machine learning. I'm wondering if there's any, pre-configured, like Paraview projects out there or something where people have had to visualize their networks.
there should be. One of the things which is on top of my head, and I remember that was for the image segmentation in 3D. That was a plugin for ImageJ called Weka, W-E-K-A. That was AI doing image segmentation, like giving like 10-bit or 8-bit image, for example, which is, or grayscale image to the program, and then getting like two-phase kind of segmented image, saying that if you remember this one, yeah, this one. It is a grayscale, could be like very colorful, like rainbow kind of color, but with that application, with the AI, you can give that like a few sample. This is void, and this is like a grain in the rock sample, and then it does the rest for you and give you like very accurate results. So yes, there are, but does it fit your purpose or not? It depends. I'm not sure. For example, that one that I remember, that was related to the geoscience. So maybe for something else, there are some others. Good. So I think there's no other question. So I bring it here. So I'm not sure. How can I unpin this one? This pinned here. Anyway, so this is the remote viz that we talk about. So for the remote viz, which is giving you, which gives you the Linux desktop or Linux-based application. So you simply go to remoteviz.pawsey.org.au with your Pawsey account. You log in. Nice. I think something's happening. Today is maintenance day. Yatu, can you log in, or is that just me?
I'll try, probably. Yeah, it's blocked.
Yeah, I think the maintenance already has started.
Yeah, I don't think I can get into Topaz, so that's
yeah. So yeah, that's maintenance. Sorry about that. But yeah, so maybe we can show you the Nebula, which is not under maintenance today. So the only thing that you have to do for Nebula is go into our reservation system and book the instance first. That's booking based. So you can see, okay, so here, visualization test, maybe extend it to 11 or to 12. It has booking, so you do similar, and then you go to Nebula and you log in, and you will go directly to Windows. So maybe you can say this is what is happening. I don't know. Yeah, I think Nebula went under maintenance as well. You have been disconnected. Oh, maybe that's I can show you at least with my admin. So maybe you can say this is a normal Windows. Yes, it is a normal Windows, and it is identical to Windows that you have at home, but the applications that you have here installed, you can interact with the supercomputer. That's the difference. Also, what we were talking, if you close the the window, for example, the tab by accident or by internet disconnection, whatever, done. Command Shift T, everything's back. So you see, for example, I have this open here. So just to give you an idea, that is not a new session, and you close that accidentally, so everything's back. So it's the same for remote with Cetonix visualization, as well as the Nebula and most of other, almost every other systems that service that we have. You don't have to have crazy machine at your end, as long as you have internet connection and browser, it's enough, and it's everything like touch enabled. So that is end of our presentation today. I love to know more about what you think. If you have any question or idea, please unmute and turn on video and come and join the discussion. I'm not sure how long we can stay here, Rick or Emily, but feel free to unmute and ask question. I should stop sharing, right?
Happy to leave the session up while we've got questions incoming.
Sure. And also, even after the presentation, feel free to reach us on through help@pawsey.org.au or visualization@pawsey.org.au. So every visualization question that you have will be directed to us, and we'll look after that one. I'm almost done with the presentation, so if you have anything, no worries. Almost, just a few more minutes. Or if you want, Eric, Emily, or Yato, just join, and if I have missed something, please continue and talk about that. Oh, Jesse's here.
Thank you.
Hi, Jesse. Yeah, no worries.
Yeah, so you know, you might have tight time frame, but I guess if you could spend some time or thoughts into how you can better visualize your data, would you know, help in communicating your outcome easily. And it could be, you know, a range of things from graphs to nice visualizations to videos to animations and so on. By the way, this lab is capable of doing 3D stereoscopic display. So if there are potential, then maybe we could, you know, help you generate some content. And I was talking with Edric just before this one, having maybe a visualization showcase towards the end of your internship. So maybe we can have some demo and discussion in the Vis Lab. Also, you know, it's a great space for collaboration. So if you are collaborating with, you know, multiple groups, or if you have multiple supervisors, maybe it's a good place to have those discussions in the Vis Lab if you are in WA.
Also, they can connect to the conferencing facilities as well. We have very like good conference facilities here. I'm sure Jesse can talk about that. But back to visualization, the first step, always remember, think about the data format that you have. As a rule of fingers, PowerView is one of the most powerful or the best example. There should be millions, not millions, tens of these applications, but it covers, I think, 140 or 150 kind of different data formats. Am I right? So you can import and open different data formats into that. It covers like wide range of data, including weather prediction, CFD, geoscience, whatever that you can think of. So far, we didn't have any problem major problem basically. Or if there's some very specific ones, for example, we had some difficulties with Silo. Silo has to be compiled to be possible to open in the Silo in Purview, but always you can write like a script to convert data, or there should be maybe pre-developed conversion applications there that you can get help of. But yeah, I think about the screen. Does you do want to give them some more information about the display system?
No, we couldn't hear you, Jesse.
Yeah, mic problem. Yeah, please.
Sorry, yeah.
Oh, no worries.
So we did have a couple of questions in the chat that I have answered, but if there's any other questions, then feel free to ask. There's
Sure. So over to you, Edric, and Emily.
Well, I guess I'd just like to encourage everyone to give the Viz service a shot. And if you're interested in it, the way you would apply is just asking your supervisor to put it through a submission. And if you have any questions about the specifics of what you should, what they'll need to do, or what they need to ask for, you can always get in touch and walk you through that. Also, alongside the showcase, at the end of the internship, we have the poster presentation session, and there's a poster competition. And this year, as part of that, we'd like to really emphasize visualization and novel use of the Viz service in our in that poster session. So think of how maybe you could make use of Viz services and be creative. If think of something, then Emily and I can't advise you or help you out on that. We can point you towards the Viz team and see if that's possible. And aside from that, thanks so much for the session today.
Thanks everyone for coming to the visualization session, and see you soon.
Thank you.
Thanks, guys.
Oh, I think you're muted.